Thank you for taking the time to watch our ProSeries monthly webinar by Protect. The ProSeries content is designed to bring new ideas, strategies, and understanding of topics to help ensure people and processes are safe, equipment is reliable, and companies remain compliant with regulatory jurisdictions. To ask a question, please click the Q&A icon at the bottom of the screen to type your question. We'll answer them as they come or hold them to the end of the call. My name is Nathan Vandergreen, CEO of Protect, and I will be your host for today. We have a great topic to share with you, which we believe is a meaningful topic with regards to compliance with the newly updated NFPA 70B regulations. Without further ado, it's my pleasure to introduce to you Elizabeth Holtrip, our Senior Manager of Engineering Services at Protect. And Elizabeth, if you could start off by giving the listeners here today a brief snapshot of your background.
Yes, I can. Hi, thank you everyone for joining today. As Nathan mentioned, my name is Elizabeth Holtrop. I have a degree in chemical engineering from Auburn University, and I started my career as a process safety engineer, providing consultancy services to mostly major oil and gas producers in Houston, Texas. Early on, I spent a lot of time in PHAs, performing consequence modeling, learning about managing and mitigating process safety risks in the energy industry. I took a role with Kinder Morgan on the corporate compliance team, managing PSM audits and PHAs across all their business units. Through that role, I just started missing the project diversity that consulting offered. About 2.5 years ago, I joined Protect with the opportunity to grow and develop the process safety and engineering services here at Protect. I now have about 10 engineers on my team located from Baltimore to California. And we've recently expanded outside of just traditional process safety and engineering services, more to mechanical integrity, environmental, and electrical engineering services as well.
Great, thanks, Elizabeth. And today we're going to be discussing the most recent changes to NFPA 70B. Can you quickly explain to the audience here just why these changes are so significant?
Yes, so the latest edition of NFPA 70B, which is a standard for electrical equipment maintenance, became effective in January of this year. This is noteworthy because for the first time, this became a mandatory standard instead of a non-mandatory recommended practice. This now puts NFPA 70B on par with NFPA 70E, which is the standard for electrical safety in the workplace. Together, these two standards require employers to formally manage electrical safety and electrical maintenance risks. NFPA 70B is not a code that's directly mandated by law. However, it is considered the minimum consensus standard for safe electrical work practices, and OSHA can now utilize this standard to issue citations moving forward.
Great, thanks, Elizabeth. And maybe if you could highlight some of the more and most important changes and expectations our customers should have with each update here.
Absolutely. So we will break these changes into 5 key changes and highlight them and go through them one by one. So the first one that we will highlight is on maintenance intervals, and these no longer being suggestions, but now they are clearly outlined in NFPA 70B. First and foremost, it's important to understand that maintenance intervals outlined in the 70B tables do not supersede any manufacturer guidelines. They only provide guidance in the absence of information from a manufacturer. You should always consult with manufacturer recommendations and guidelines first and ensure you understand, maintain, apply, and train on the manufacturer guidelines for each electrical component in your system. If you defer to the maintenance intervals outlined in NFPA 70B, you will notice that most of the intervals vary from frequency between 12 months and 60 months for condition 1 components, which are the best, I guess condition 1 is the best rating you can have, which is defined as being installed as new or in excellent condition, and when they're non-critical components. On the other end of the spectrum, you have condition 3, and these intervals range from 1 month to 6 months to quarterly intervals. The maintenance intervals listed include multiple types of inspections. So you have your visual inspections, cleaning, lubrication, mechanical servicing, and electrical testing. So you're not just looking at your annual IR inspections, which you traditionally complete. Now you have 5 types of inspections that must be managed. And they don't always have the same maintenance intervals. So not only must you manage each component type and each inspection type, but they also must allow time necessary for corrective actions, repairs, and any deficiency management that's identified through those inspections.
Right. That is a significant change in day-to-day operations for most companies. And that was only the first section. What else, really do you have to lay out here, Elizabeth?
Yeah, it just continues to get more involved. A big part of why we wanted to provide this resource is that these updates could be challenging to implement, and they will be even more challenging to maintain without proper understanding. I am only highlighting the key changes here. There are 38 chapters and 14 annex sections as part of this update. We won't touch on each of those changes, but it's important to understand that facilities can't just pick and choose 3 of the 5 key changes. All 5 must be adopted for compliance. So the second key change that we'll cover is equipment condition assessments. So the maintenance intervals we just discussed are based on an equipment condition assessment. This assessment has several stages. It's an ongoing assessment and requires documentation, continuous review, and training to make sure that this assessment stays up to date. So the equipment condition assessment process includes assessing 3 conditions for each electrical component. And these 3 conditions are the equipment's physical condition, the criticality, and that can be the downline assets or processes that are not defined in that determination. And the third is the operating environment of that component. So each of these 3 elements will be rated as condition 1, which is your best possible condition, condition 2, or condition 3, which is your worst condition. And previously noted, maintenance intervals are based on the component itself, the condition 1 through 3 value assigned to the component, and the equipment condition assessment is driven by the highest value seen in any of those 3 conditions. So for example, if a component in the system is rated as a condition 1, but the environment is condition 3, then the whole system would be rated as that condition 3. So it automatically defers to kind of that worst condition and assigns that to the entire system. So in addition to the actual rating process, a decal system is now required. A color-coded decal must provide a visual indication of the electrical equipment condition of maintenance. The decal requirement will involve condition rating training, employee responsibility assignments, and continuous review as the system condition rating changes over time. And then on the next slide here, we just have the 3 physical conditions listed out with identifiers for each of those conditions. So again, like I mentioned, the physical condition 1 is the best possible rating. This is going to be for your new components or your components that appear in a like new condition. The enclosure is free of moisture, clean, and tight. There are no unaddressed notifications from continuous monitoring systems, and preventive maintenance techniques do not generate active recommendations. So in other words, all previous maintenance has been performed in accordance with your electrical maintenance program, and there aren't any outstanding actions on that. So for your physical condition 2, that's going to be assigned where any of the following apply. So that can be your maintenance results, deviate from past results, or indicate that a more frequent maintenance interval is required. So this would include scenarios where previous maintenance activities revealed that the component needed repair or replacement of any major components with that equipment. So if there have been any notifications from the continuous monitoring system since the last assessment, that automatically puts it into a condition 2 category. And any predictive maintenance and techniques that generate active recommendations would also bump this into a condition 2 category. And condition 3 is the lowest of the rating. It's assigned where changes in operating conditions have been noted or when any of the following criteria apply. So that could be the equipment has missed the last 2 successive maintenance cycles required by the electrical maintenance program. Both of the previous 2 maintenance cycles have revealed issues requiring repair or replacement of major equipment components. If there are any unaddressed or active notifications from the continuous monitoring system or any predictive techniques that generate urgent action steps. So that could be fault ratings from IR inspections or NETA fault ratings of 2 or 1, for example.
Wow. Sounds like becoming compliant with this isn't going to be such an easy process. A lot of involvement with inspections, new equipment ratings, and every part seems to require and need new and updated training. Is that fair?
Yes, absolutely. You're right. There are a ton of updates and a ton of information involved in reviewing these updates. This third area that we will discuss is the actual required electrical maintenance plan. So this is the fundamental plan that's going to govern the outcome of the interval inspections and condition assessments that we just discussed. So section 4.2 is going to define and outline the requirements for each required element of your electrical maintenance program. So just adding the plan to your operations will require many steps, and of course, each include record keeping and employee training to be documented on these steps. Your electrical maintenance plan must also be accessible for employees so that they can access this information and understand how these details could impact their day-to-day jobs. So the details of the code read the electrical safety program shall be in place. Employees responsible for program elements shall be documented. So we'll need an org chart associated with this plan. You shall survey and provide analysis of electrical equipment and systems to determine maintenance requirements and maintenance priorities. So that was discussed above through the condition assessments and assigning those conditions and maintenance intervals appropriately. Maintenance procedures for each piece of equipment need to be developed and documented, and a plan needs to be created that outlines inspection services and suitable test methods. This also involves defining deficiency management, personnel responsibility, and timeline for action closures that are identified from any deficiencies through those inspections. Also, we need to develop record retention policies and plans, create a process to prescribe, implement, and document corrective actions based on any collected data, and to periodically review and revise the electrical maintenance program and consider failures and findings for continuous improvement within the plan to make sure that it's an evergreen process. So similar to implementing a robust PSM mechanical integrity program, this will be a large undertaking and is going to be an area many companies may struggle to maintain and fully comply with. This single section will be difficult to achieve without company or at least facility-wide agreement and commitment from maintenance personnel management all the way, down to each employee level. However, once this electrical maintenance plan is defined and employees understand and commit to the requirements, maintaining the requirements will strongly benefit electrical system operability as well as personnel safety.
Yeah, I'm glad you added that. It sounds eerily familiar with an MI program as part of PSM. So from what I understand, Elizabeth, um, that's just a very introductory look at some of the projects that will need considered for the EMP or the maintenance plan. I imagine everyone's looking for some help in some form by now, especially if they've known about it and heard about it. Can you give us some more information on the fourth key element?
Yes, there is no question that having someone committed and capable on your team is a critical part of implementing these updates. So the fourth key area defines field testing, test methods, and preventive maintenance activities. Chapter 7 and 8 of this document outline the definitions for testing category types. So compared to previous versions of 70B, the scope of preventive maintenance and the testing of any type of component is defined much more clearly, but it's important to note that it also outlines 4 specific test types, each of which shall be used as directed, and that direction shall be stated clearly in your electrical maintenance plan as previously discussed. It's important to note that in this section, that once again, language is included that specifically states that manufacturer recommended guidelines supersede these requirements. So it's really important to also reference those manufacturer requirements against any of the tests that you see outlined in NFPA 70B itself. So in terms of specific tests themselves, Chapter 7 lists the fundamental test. So that covers the conditions that warrant testing, the specific tests to be used, and the voltage or any other considerations that should be included when determining a particular test, and sometimes multiple tests which need to be named. So there are test methods that should be used when you have over 1,000 volts. That should include testing such as resistance testing, over potential testing, voltage testing, things of that nature. There's a full list in NFPA 70B itself. The next method is infrared technology. So IR shall be used when required to verify temperature differences. And there are several scenarios outlined in NFPA, which will outline the IR requirements. Risk assessment special consideration shall also include electrical, mechanical, chemical, and environmental testing now. And there are 4 testing category types. So each component is giving one or more tests that shall be implemented as scheduled in the update. Each test required will fall under one of the categories. So you have online versus offline and standard versus enhanced. So each system, process, and component shall have a test category assigned and the frequency of testing notation outlined. And you can find a lot more details around those specific category types in the standard itself. In addition to those testing types, the documentation and records must also be maintained for all categories of tests performed on electrical equipment. So the test record itself shall contain the following information as a minimum. So just like a mechanical integrity program requirements, all test records should have the identification of the testing person or the organization completing the test, the identification of the equipment being tested. So this can be your nameplate, your panel notation, or any label data that's on the equipment itself. The environmental conditions such as humidity, ambient temperature, solar load, wind speed, things of that nature that could affect the results of the test or the calibration. The date the test was completed, an indication of what kind of testing was performed, an indication of the results of that test. So if it's a pass or a fail criteria, make sure that's included on the record itself. Any comments the testing operator has, and that will also include any recommendations if any recommendations were made. And the condition of the maintenance shall also be included on that test record. So the field testing and test methods are also required to be included on the decal system. So the decal system has some ratings as well. So it has serviceable for any equipment that passes the test and is mechanically and electrically sound. That should be designated as serviceable with a white label. Anything with limited service is going to be equipment that has problems that are not defined to the protective operation or design. And that should be indicated with a yellow label. And then anything determined as non-serviceable will be equipment that has problems that is detrimental to the proper electrical or mechanical operation of that equipment. And that'll be noted as red. So each rating shall be displayed as a decal on the outside of the equipment. The date of the last inspection and the name of the inspector should also be included on that decal. And there's a lot more information in the code itself on what is to be included on that decal system too. So be sure to pay close attention to that.
Yeah, Elizabeth, the fourth area really seems surprisingly involved. There are additional tests added and new record keeping requirements, as well as brand new decal systems. It seems like a lot of detail and a lot of work to go through, but likely meaningfully so. Highlight the fifth key change for everyone, if you could.
Yeah, so the final key change relates to more testing, specifically entire facility and system testing. There are system studies outlined in NEC, NFPA 70E, and now NFPA 70B that provide detailed requirements for system studies. For all types of studies named below, the mandatory minimum period, so interval between studies, shall not exceed 5 years. So that's going to include your short circuit analysis, your coordination studies, and incident energy analysis. It's important to note that each of these studies must be reviewed, verified, and potentially modified to align with the scope standard. Additionally, your single line diagrams to calculate the short circuit values and protective device clearing times that ultimately determine the arc flash values and PPE requirements must also be reviewed and updated. So this requirement will be seen in the electrical maintenance plan. Up-to-date, accessible, and accurate single line diagrams are now required. and are mandatory for that system study data to be most up to date and accurate. So listed system tests are going to be your arc flash studies, also known as your incident energy analysis. And these do typically include the coordination studies and the short circuit studies. There's also the addition of the load flow study, which is the overcurrent protective devices and equipment ratings that must be verified. There's some requirements for equipment cleaning, for spare part inspections, as well as reliability studies and maintenance related to design reviews in order to reduce risk. So where you previously had your arc flash study every 5 years, you now have to complete each of the tests and studies and analysis listed above. So it'd be good to consider scheduling all of these to be completed during the same 5 year cycle rather than trying to have them all completed in the 5th year. So please note that the 5 years is the maximum period between tests, but there are now specifically listed events which would require each of these system tests to be performed or updated. So for example, installing new electrical equipment might warrant that you do some of these tests or updates before you meet that 5 year compliance cycle, just to make sure that your one lines are up to date as you make changes to your systems.
Elizabeth, I know we obviously don't have enough time to go through this entire new program, and I think you mentioned 38 sections and 14 appendixes, and but each section that you've went through so far seems to introduce large, sometimes facility-wide requirements and conditions. There's no question the ongoing training and constant record-keeping elements are more than enough to try to manage. Every customer should be making plans on how they hope to proceed from here, I would assume.
That's correct. These requirements will impact pretty much every industry and company type. In summary, these are just 5 key areas, and they have many action steps for each of the key areas and include a lot of additional training requirements to really understand and comprehend what is required. It should be noted that there are very large-scale expectations regarding documentation and record keeping in the updated NFPA 70B document. The creation of an electrical maintenance plan will be a major requirement and will likely be an area OSHA will include in its inspections and really hone in on. So gathering, prioritizing, and classification of data and documentation for each potential electrical component is going to be a large undertaking. Equipment condition monitoring and maintaining decals is going to require, constant and continuous review and revision to make sure that those are installed appropriately and up to date. Periodic maintenance will have to continue. And then as it does, make sure you're maintaining the appropriate record keeping guidelines and specific tasks are documented based on the different types of electrical systems and components that you have installed. You will be required to have infrared inspections completed as well as other inspection testing methods, as we noted above, such as that insulation resistance testing, inverse time trip testing, instantaneous overcurrent trip testing, and then, of course, the arc flash requirements that we just discussed. So a big key takeaway here is that if you already have an effective CMMS or preventive maintenance program, you should be able to build an electrical maintenance program that you can easily integrate with your existing mechanical integrity programs. You'll just need to pay close attention to manufacturer recommendations and defer to those NFPA guidelines on intervals or criticality for any items that you don't have specific details from the manufacturer, just to make sure that those pieces don't get missed as you're building out this program. And so in closing, I know this is a lot of information to digest and to get through in just about 30 minutes, but we're here to help. So from helping you establish your electrical maintenance programs to developing or updating single line diagrams, or performing or revalidating arc flash analysis or short circuit analysis, we're here to help you guys make sure that those are all up to date and reviewed appropriately, and these programs are built out and implemented for compliance. So feel free to reach out. We can help make compliance with these updates manageable and also help with training and awareness for any of your team members.
Thanks, Elizabeth. Appreciate the insight that you provided. I know many people are wanting to understand more about compliance with the plan for NFPA 70B. We're going to take a moment to answer any of the questions that have been submitted throughout the course of this. So I'm going to pull those up here. And the first question I have here is this something we should be able to just adopt here and there until completed, or do we have to go all the way there at once?
Yeah, so unfortunately, all the NFPA updates are now mandatory. So 50% compliance is not compliant. So definitely need to take into consideration all of the considerations here that are part of the update. I mean, again, I like to touch on the PSM Mechanical Integrity Program. These requirements are very similar to the documentation that's required there. The big, I guess, addition that you would have to do here is adding in that electrical maintenance program condition assessment. So making sure that you assess the condition of each component, and that is brought into the maintenance intervals as part of that program. So that's going to be the big, I think, undertaking that a lot of facilities are going to want to start with.
I really like the correlation you draw between the two. It's easy to think about, your electrical equipment is critical equipment, and that's why PSM required mechanical integrity program, and I think it's a good correlation to just get people's head around it. Another question I have here is, how long would this process last? If I started today, when could I be compliant?
So that's a tricky question, I would say. So it is a pretty large project and undertaking with a lot of moving components to get up to compliance with these updates. There are steps that will have to be taken first and completed, and of course, trained on before the program can be fully implemented. So an example of that's going to be, the criticality assessment. So putting together a team that's trained on assessing, each component and staying consistent across the component assessment, and walking down electrical equipment, completing that assessment. That's going to take quite a bit of time. And then assigning intervals based on that assessment is going to be that next step. And then making sure that's part of, your tracked CMMS or whatever your maintenance management program looks like at that point. I do want to key on the fact that this process is ongoing. So by the time you do get up to compliance, you may need to, continuously check the schedule, make sure that field testing and repairs or cleaning are always being maintained. So that's where having a CMMS or a computerized maintenance management system is going to, really help take a lot of the legwork out of this. And then making sure everyone's trained on that. So while I don't know if I can give a short answer on how long this is going to take, I think, it's going to take a month or so just to wrap your head around what that assessment looks like, really assigning what those frequencies should look like. But I think, within a quarter, this is something that you can get that training completed. You can do that assessment. You can outline what those intervals are, and then you can just start, knocking away at each of the components and those maintenance activities. And so I think just taking it in small bite-sized pieces one at a time and shooting for getting something completed each month, within a quarter of really dedicated work, I think someone could have a really good start at getting this underway.
Cool. I don't see any other questions here right now, and we're at 30 minutes, and I think we'll try to keep it at that. So I want to thank everyone for joining us today. The recording of this webinar will be emailed to attendees as well as posted to Protect's website and YouTube channel for you to share with your colleagues. If you'd like to have us visit your site or learn more from us about NFPA 70B and the compliance plan for your company, please reach out to Elizabeth, myself, or your Protect representative. Elizabeth has some very exciting breakthroughs in the electrical services area, so please catch up with her sometime to go through those and a few other programs that she's helped us develop at this company. So again, appreciate your time, and thank you for joining.
Thank you.